What's up guys, this is Masi, welcome to my channel. This video I want to show you how to calculate the pH of strong acid solutions. Strong acid solutions, basically when you dissolve strong acid in water, it dissociated right away into its ions. So you will not find any undissociated or original form of acid when you dissolve it in water. So let's see some examples. When we deal with acid-base equilibria, we must focus on the solution components and their chemistry. For example, what species are present in a 1 molar solution of HCl? Since hydrochloric acid is a strong acid, we assume that it is completely dissociated. Thus, although the label on the bottle says 1 molar HCl, the solution contains virtually no HCl solution or no HCl molecules. Typically, container labels indicate the substance or substances used to make up the solution, but do not necessarily describe the solution components after dissolution. Thus, 1 mole per liter HCl solution contains proton and chloride ions rather than HCl molecules. So for example, let's see how to calculate the pH of 0.1 mole per liter HNO3, which is a strong acid and it's called nitric acid. Since nitric acid or HNO3 is a strong acid, the major species in solution are proton, nitrate, and water. The concentration of HNO3 is virtually zero since the acid completely dissociates into water. So because it's strong acid, we don't have any original molecule left in the solution, so it's completely dissociated into its ion, which is proton and nitrate. Also, hydroxide concentration will be very small because the proton ions from the acid will drive the equilibrium. So as you see here, proton concentration is much greater than hydroxide concentration, so hydroxide concentration is going to be very small. So now let's find out the concentration of proton. It is 0.1 from nitric acid and 10 to the power of -7 from water, so which is negligible comparing to 0.1 from acid. So the number of proton ions contributed to the ionization of water will be very small compared to the 0.1 mole per liter contributed by the nitric acid and can be neglected. Since the dissolved HNO3 is the only important source of proton ions in this concentration, we can say proton concentration is 0.1 and pH will be negative log 0.1, which is 1. Now let's see this example. We want to find out the pH of strong acids. Calculate the pH of 1 times 10 to the power of -10 molar HCl. So here HCl or hydrochloric acid is a strong acid, but the concentration of hydrochloric acid is quite low. So let's see what happens. So normally in an aqueous solution of HCl, the major species are proton, chloride, and H2O. However, in this case, the amount of HCl in the solution is so small that has no effect, and the only major species is H2O. Thus, the pH will be that of pure water, which is pH equals to 7, because the concentration of proton is 10 to the power of -7 comes from water, and 10 to the power of -10 comes from the acid, so which is negligible compared to water. So 10 to the power of -7, and when we find the pH, it will be 7. So although we have a strong acid, since the concentration is quite low, the proton coming from water is the major one, and that defines the pH. Thank you for watching. I hope you enjoyed this video. Please like this video if you found it interesting and useful. Please don't forget to subscribe to this channel. You can find out lots of videos regarding math and science. Thank you and have a great day.